As he said, my name is Nicole Newlist. I'm otherwise known as Rogue Clown. I think there are more people here who know me as Rogue Clown, Hey Blue, what I answer to just about anything. Know me as that than Nicole, but like I said, anything's good. And I'm here to talk a little bit about open source tools for musical exploration and composition. First, a few words about me. And yes, that is a picture of me singing karaoke at a bar in Chicago a little while ago. I'm pretty good at singing. I mean, I've been singing in choirs and since I think I started in my first choir when I was 9 years old, 5th grade. And I mean, I'm still doing it now. And I'm interested in composing music. You know, I started with like little piano things when I was taking piano class for those 6 months when I was 9 or 10. And, you know, I've done a little composing here and there, taken a bunch of music theory classes. I'm pretty good with computers, but I'm really bad at operating musical instruments. And if it's something that I can't sing or if it's more than one line at once, you know, it's kind of hard for me to be like, hey, everyone, come out here, you know, sight read this stuff. I want to figure out what this is saying. I want to figure out, you know, how my compositions, how my ideas sound when they're realized, what the harmonies I'm setting them up for. And since I can't really play them on a keyboard very well, given my complete lack of finger dexterity, what can I do? I can use a computer. Now, a few words about what this talk is. It's a practical survey of available open source options for musical projects. I'm going to go over things that are useful for editing existing compositions, you know, be it things you've written in the past or things other people have written that you want to, you know, remix, sample, reprocess, just generally mess around with, and things that are useful for creating your own compositions. I mean, honestly, they're just given the nature of using computer tools, there's a lot of overlap. You know, the program doesn't know the difference between a file that's somebody else's and a file that's yours, you know, putting aside ridiculous DRM stuff, because, hey, we're talking about free software here. That's a little beyond the scope. I want this to be accessible for beginners. I don't plan to get stuck in any kind of jargon, but if I do get stuck in any kind of jargon or I'm saying some words that you don't quite understand, please, in the middle of my talk, raise your hand, just start yelling at me. I really don't care. You know, the point is not that I go through for the next 50 minutes without any interruption. The point is that you understand what's going on and that you leave here with some sort of an idea of how to use some of these tools to start messing around with computer music. I also hope that some of these tools are ones that if you have played around with computer music before, but either haven't used free software yet or have, but have only used a certain limited amount of tools, maybe you'll leave here with a couple more things in your arsenal. And also, quite importantly, it's all free software, but it's also cross-platform. You know, a lot of people associate free software with Linux. And yeah, there's free software Linux that is a pretty big community, but most of the software that I'm talking about today runs on more platforms than just Linux. You know, my own background is Linux, but most of the stuff runs on Mac or Windows or both. Now a few words about what you're not going to get out of this talk. It's not an exhaustive manual for any piece of open source software. I'm not going to touch on every single capability of every single piece of software because, my goodness, if I came up here, I could probably, you know, there's probably more than an hour of material on, you know, just Ardor or just QSynth or anything like that. I can't go into every single detail of every single piece of software. It's not a class on music theory or a class on musical composition techniques. So stuff I'd be perfectly happy to talk to you with, you know, off to the side, either after my talk or, you know, after a few drinks at one of the parties, but it's a little beyond the scope of what I'm getting at here. So kind of the topics that I'm planning on covering. First, I want to say a few words about why open source, why I got started doing musical composition with open source software, and why it's a good idea for people who want to experiment with stuff to use open source software for computer music. Then I'm going to talk about the building blocks of computer music, just the general categories of programs that can be used. Then I'm going to talk about making sounds with software synthesizers. The focus is going to be on software and not hardware because, well, this is a talk about open source software. I'll talk a little bit about how hardware fits into it. There are, you know, hardware synthesizers, hardware sequencers, those kinds of things that exist, and you can probably solder your own together over in the hackerspaces room. But again, that's a little beyond the scope of what I'm getting at. Then I'm going to talk about creating musical structures using sequencers, score frameworks, algorithmic composition frameworks, things to actually, you know, make those notes, those sounds that the synthesizers will make into pieces of music. Then I'm going to talk about what's available to connect to those building blocks. I'm going to talk then about some audio processing software if you already have something that's tracked, or a WAV file or a MIDI file, something like that, some programs you can use to mess around with that. And then finally, I'm going to talk a little bit about Ubuntu Studio, which is a Linux distribution that is focused on multimedia work. And will help you put some of this into practice if you just want to tinker around with it. First, why open source music software? I got started because I got into computer music after I started using Linux. I mean, even though I've been singing for years and years and years, I really didn't get started playing around with a lot of computer music until the last few years. Linux has been my only desktop OS, my only OS that I keep at home, except for, that Windows virtual machine just in case I go to some website that doesn't work in anything but Internet Explorer. Boo hiss, gonna end that rant here. Linux is my only desktop OS. So how did I find software to use when I wanted to, learn my choir part or something like that? I Googled, score framework Linux, blah, blah, blah. And it came up with open source software to use on my Linux system. Why should you go open source? First off, you're not made of money. If you just want to tinker around with some sort of software, figure out how it works, figure out if it fits your software usage patterns or how your brain works when it comes to musical composition, you're not going to want to drop like hundreds of dollars on a piece of software just to find out that it really doesn't work with how you think. That sucks. Whereas open source software, you can download it, it's completely free, you're not pirating anything, you're not violating any licenses, it's there. And also, the documentation. There's a lot of, pretty good online documentation for all these pieces of software I'm talking about. There's forums where people are discussing how it works. And, if you want to bug the developer on IRC, like if you find a problem with it, it can be pretty easy to get in touch with, say, hey, I found this, get a dialogue going. I don't run Linux, like I said, that doesn't matter. Even though open source software is often associated with Linux, the stuff I'm talking about today is cross-platform. So now with that out of the way, I'm done with the open source evangelism, I promise. Let's talk about how you can make some noise. First, I'm going to talk about just the building blocks in case some of you haven't made computer music before. Basically, controllers and synthesizers are the two main building blocks that I'm going to be talking about. Now think of a traditional musical instrument. You're standing in front of an old school piano. You push a key, you hold it down for a certain amount of time. You push it hard, it's going to be a sharper sound. You kind of softly touch it, it's going to be a little quieter, a little rounder. You hear a sound. On a computer, you have software that allows you to define that pitch, that time, that articulation, that sound quality, and you hear a sound. And it's kind of nice because with some of these computer software, you can create a pitch, time, articulation that may not actually be able to happen with, let's say, a real live French horn, and yet associate it with the sound, synthesized French horn sound, and you can make these sounds that you're not going to actually be able to get out of traditional musical instruments. And I know, at least to some people that make computer music, there's a huge allure in that. It's actually really cool that you can make instruments sound like they were never intended to sound like. Now controllers, it's kind of like the keys you push. There are hardware controllers, a keyboard, a drum pad. You can make your own with microcontrollers. At the end of the talk, I'm going to give you my website. These slides are going to be up as soon as I get back on a computer to upload them. I also have another talk that I gave at Penguicon last year about how to make your own musical instruments using Arduino. It's not as hard as it sounds. If I can do it, anybody can. Really, any hardware that translates your interactions with it into melodic data is going to be useful as a hardware controller. There are also software controllers. The first one I started playing around with was called VMPK, which is the Virtual MIDI Piano Keyboard, I believe that stands for. Basically, it's just a little window on your screen that looks like a piano keyboard, and you can move your mouse and click the keys. That got pretty clunky pretty quickly, and it became not my primary MIDI controller anymore. But it's a pretty good example of a pure software controller. There are keyboards built into other software. I'll have a screenshot of one of the synthesizers that I use sometimes, and it's got a piano keyboard on there. Also, there are programs that generate melodies that fall into that category of controllers. Sequencers, score editors, algorithmic composition, anything that's like, okay, here's a list of notes and MIDI messages to shape that note. That's a controller. I mean, that's a software definition of pushing down the key. Then there's synthesizers, the instruments that you hear. There are hardware examples of synthesizers, commercially available machines with built-in sound banks that you feed information into and it makes the noise. Again, you can make your own with microcontrollers. I touch on that a little bit on the talk that I mentioned in my website, the one I gave at PenguinCon last year. Software synthesizers, I'm going to talk about a few of those in this talk. A lot of them, just right out of the box, they have a full range of synthesized instrument sounds. Sometimes it may not have as many, or there might not be one that you want. You can create your own sound by modifying the waveforms, or a lot of times, you can just Google around, look around. People have made banks of sounds that you can use with existing soft synth frameworks. I love software synthesizers. They're awesome. It's the first thing I'm going to talk about, actually, open source software synthesizers. The first one I ever used, and a really good one to start with if you're kind of learning the ropes on software synthesizers and learning the ropes on music, is called Zinad SubFX. It's kind of a funny name, kind of clunky, but it is a really good software synthesizer to start with. Because to make it make noise, you're not going to have to deal with, plugging it in through any sort of sound server framework. You can open it up from your menu and start tinkering around with it, and it actually makes noise. There's a piano keyboard on the screen, or you can type keys on your keyboard and it will make noise, which is awesome, because I'll just start typing words or start typing phrases, and sometimes certain words or certain phrases will sound really good. I mean, that's a lot of times I ended up doing that. Maybe a year ago or so, we'd have these monthly unusual musical instrument nights at Pumping Station 1, which was a hackerspace in Chicago that I belonged to. And sometimes my contribution to the unusual musical instrument night would be just finding sentences or phrases or words that sounded really cool and typing them over and over again as kind of an ostinato, which is really just a repeating pattern for other people to play their instruments over. It's a lot of fun. Problem is, though, when I started exploring around more with MIDI and making my own MIDI controllers out of Arduinos, I found that when trying to connect it to other things, it was just slightly MIDI non-conforming enough to be a royal pain in the butt, which is why it's not my primary software synthesizer anymore. It is cross-platform. You can, there are official releases for Linux and Windows. There's also a port that the community made for Mac OS X, and there's the website where you can download it. If you do run Ubuntu or some flavor of that, there is an official package manager. It's available through the package manager as well. apt-get Zinad SubFX, and you'll have it. But you can download it on SourceForge. This is a screenshot just so you can see the user interface there. At the bottom, you'll see this is a piano keyboard. You can change how many octaves the keyboard has, change the MIDI channel if you have different banks tied, different instruments tied to each channel. How low or how high it goes, 0 and 127, that's the range of numbers assigned to pitches in MIDI. You can click there. If you click that, then it pops open I believe that's my next slide, actually. Yeah, you click there, it pops open different banks. You can drop this down, and there'll be just a list of different banks. I mean, this is only one of the many banks that it comes with by default, which is another reason that Zinad SubFX is a really fun way to get started, just learning the ropes making music with your computer, because there's just so many sounds that come with it, and a lot of them sound pretty cool. Now, Fluid Synth and QSynth, that's become my default framework for software synthesis at this point. It turns MIDI data into sounds using sound fonts, and sound fonts is a fairly old technology, but it's cool because it's derived from the real sounds that real instruments make, and the goal is to turn that into some kind of digital pattern that your sound card can play. And it used to be a real pain in the butt because you had to make sure that your sound card supported this sound font stuff. But Fluid Synth is a software layer that makes it so that your sound card doesn't have to specifically be made to do sound fonts anymore. If you've got Fluid Synth and you find any kind of sound fonts, sound banks online, you should be able to play them using Fluid Synth. QSynth is just the graphical front end to it. You can also use it to convert sound to raw audio format or WAV file format for either further processing or to play for your friends. It's nice because I haven't run into any MIDI compliance issues in FluidSynth QSynth. I've had no problem connecting this to any controller I wanted to. And it's available for either Linux or Windows. This is a picture of some of the main windows of QSynth. You can see the top. You can mess around with the with the waveform. You can add some chorus effects, change the shape of the wave. These are just the sounds that come with one of the banks that comes with it by default. Again, what's really nice is if you find any kind of list of bank of sound font sounds, you can probably run it through FluidSynth and QSynth. One other synthesizer I'm going to talk about is Hydrogen. It's a very specific one, specifically if you want to make drum patterns. And it's a lot of fun, really easy to get the hang of. You can create them, shape them, layer them, track them. It's originally for Linux, but it has been ported to Mac OS X. There used to be a Windows port. It went dormant about 2006, but in the most recent snapshot, there is a Windows port again. So if you run Windows, look for a port of Hydrogen in the near future. What's really nice is this is just what you get when you open the program. So 1, 2, 3, 4 beats in a measure. You can change the gradations within a measure, kick, stick, snare, jazz, hand clap, etc. Wherever you click, that's the beat where that sound is going to show up, and pretty soon you're going to have an interesting little drum beat going on. Again, it's a lot of fun to play with, and the learning curve in Hydrogen, not very steep. Now that you know of a couple of programs that you can use to make sounds, what are you going to use to make those sounds have some structure? Actually, kind of make some music out of those sounds. Flesh out your ideas. First of all, I'm going to talk about sequencers. Now, they're called sequencers because back in the day, that's pretty much all they did. You had this hardware box. It was a grid of 16. And, okay, here, 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 and here, it's going to make this noise. You chain the patterns. It makes longer compositions based on the loops that you've made in the synthesizer. Ready to go. Modern times, sequencers are a lot more than that. A lot of programs that we'd call sequencers nowadays are full-featured digital audio workstations. Hardware sequencers still exist. They're not quite as popular anymore just because of the lower cost and larger feature set that it's feasible to get in a software sequencer. Now, the first sequencer I'm going to talk about is very stripped down like the original hardware sequencers. It's called Seq24. I think that's how it's pronounced. I've always seen it written, really never said. But it's a loop-based MIDI sequencer. You can either record loops in real time with a MIDI keyboard or controller that you have attached, or you can open up a piano roll and do it note by note and play it back. You can edit the timing, the articulation, and layer the loops together. Like I said, it does a few things, and it does a few things very well. It's nice because you can get it for either Linux or Windows, and MIDI keyboard, computer keyboard, or mouse. There are several ways you can enter data into there. These are kind of the main windows of Seq24. This is the piano roll display, and beat number 1, 2, 3, 4 of a 4/4 measure. If you don't necessarily know music jargon, please forgive me if this is basic for any and or all of you. But a 4/4 measure is 1, 2, 3, 4, 1, 2, 3, 4. 4 quarter notes per measure, just a pretty basic meter when it comes to music. And here you've got, and there's kind of a piano display here, C, D, E, F, G, etc. And you can enter notes here. And then this is just the velocity, or kind of how hard you hit the key. So I have it kind of ebbing and flowing through the course of the measure. And I've got that, and then I've got another different thing that's layered on top of it. So then when you play this, it would play both of these over each other. It'd play both of the loops. This here is, just you can get the list of all of the loops, and if you double click on this, you'll get this, and you can just start screwing around with all of the notes. I entered these just using the mouse, although you can also use a keyboard, your computer keyboard, whatever suits your fancy. Then there are more complex sequencers, and this slide got really screwed up for some reason. They combine looping features with recording, layering, processing features. Not only do you enter music note data into it, but you can give them, WAV files, MP3 files, depending on, what features your sequencer has, and you use it to process and mess around with sounds. There's a program called Ardour, which is probably the, slickest, most feature-rich of the open source sequencers. You can run it on Linux, FreeBSD, Mac OS X. There's not a Windows port right now. You see some, mumblings in the community about having one, but the main developer of Ardour, not so crazy about it. One interesting thing about Ardour is there's a program I'm going to talk about later, which helps you connect all the programs together, called Jack. And since the main developer of Jack and the main developer of Ardour are the same guy, the Ardour and Jack integration is really, really good, unsurprisingly. There's another one called Muse, which is Linux only, and then another one called Rose Garden, which is Linux only. One nice thing about Rose Garden, we'll get some screenshots of all of these in a bit. Rose Garden, unlike Ardour or Muse, also has a score editor feature in it, which is nice if you're like me and you're most comfortable in, the 5 lines, treble clef, bass clef, quarter notes, half notes sort of realm. The nice thing about computer software is you don't necessarily have to read music to make it do some really cool things, but there are certain programs which are extra special awesome if you do know how to read music. Muse used to have that feature built into it, but it was actually forked off, and now it's a separate program that I'm going to talk about later. This is a screenshot of Ardour, and this has just 14, 15 more different loops going on. You can mix them into and out of each other. It's a full-featured digital audio workstation. You can, it deals with not just, the MIDI stuff like the Seek24 does, although it does deal with it, but you can do full tracked audio work on Ardour. Muse, these are some of the common Muse windows here. This is, as you can see, very similar to the one window. The piano roll display is the term for it, from Seek24 that I showed you, with the different notes and how they're layered together on a graph of the beats of the measure. Here there's a drum display. Hydrogen isn't the only program that allows you to do drum controlling. Muse allows you to do that too. This is the sound mixer for Muse, and then this is the loop display, so you can see the different loops that you have going and how they fit together, which one's going to be playing at any particular time beat of the measure. Rose Garden, these are a couple of screenshots of Rose Garden. This is, again, kind of like that last window that I pointed at in Muse, where you see the different things that are playing all over each other at any given point in time in your composition. This is the piano roll display, the note editor. This is another note editor. This is what I was talking about with the, it's really light, you can't really see it, but it does have, the 5 lines. Like, this is the normal musical staff. So if you're more comfortable using that than a piano roll display, you can. And then this is the drum interface. Now I'm going to talk a little bit about score editors. Like I said, Rose Garden has a score editor feature of it, but there are a couple that I want to touch on that are dedicated score editors, if that's your thing. I love score editors. Like I said, I'm, unlike a lot of computer music people, I am most comfortable in the 5 lines to a staff sort of environment. And what's nice about those is not only does it create formatted score files that you can, print out and give to your friends to perform, or print out and give to your choir to sing or whatever, but they do allow you to save it as, MIDI files, more common portable files, so then you can put it into one of the, into a sequencer or digital audio workstation, or really any other program that'll let you tinker around with MIDI and tinker around with it in that environment too. It's useful for composing your own music, and it's also useful for learning and playing existing music. I mean, I would never learn all of my pieces for choir if it weren't for the fact that when I get my piece of music, I sit down, I type it into my score editor, and then I have a track that I can put on my iPod after a little bit of processing, which again I'll get to later, to how to get to that point. And I can listen to it on the bus or listen to it when I'm at work, and I learn my songs that way. Dynamo, that's come a lot in the last few years. I started using it back in 2008, and it was really clunky and buggy. I didn't like it very much, and I got back to it within the last year or so. It's made a lot of progress. And it's nice because the keyboard configuration is so configurable that it's like, oh, it would make sense for me to hit these keys for a quarter note A to show up. I configure it that way, and it's become almost as typing a song into Dynamo has become almost as intuitive as typing text into a word processor is for me, just because I've configured the keyboard shortcuts to what makes sense in my head and use them so much that it's just like regular typing. Dynamo is a graphical front end to an open source score engraver framework called LilyPond, and a score engraver is basically something that allows you to print out scores that look nice and pretty like you'd find in a music book or something. You can save it as a score. Dynamo has its own XML format, just markup that Dynamo understands, or you can save it as MIDI, which is nice because then it's portable to other applications. Save it as an image if you want a picture of your composition to come up on your website or whatever. It runs on Linux, runs on Mac, runs on Windows, and I think Dynamo is pretty darn awesome. This is a picture of just what the interface looks like with a piece that I'm in the middle of working on right now, actually. And I haven't written any lyrics for it, but there's a way you can put lyrics under the notes. You can enter it with a mouse, click on a half note and then click on that to make it a B flat. But then there's also keyboard shortcuts, like I said. You can change the key signatures, the time signature, the clef, the notes, and like I said, it's score editors, or if you're comfortable with the traditional music notes interface, they're fabulous. One other I'll bring up is MuseScore. It was part of the Muse sequencer. They decided that that was trying to make that one program do too much, so it was forked off. It's now its own project, a dedicated score editor. Like you can use the mouse, keyboard, MIDI controller to enter it. What's nice with Muse is if you really like Fluid Synth, it is pretty well integrated with Fluid Synth, so it's something to look at there. You can save score form, MIDI form, PDFs. As far as I know, you can't make a PDF on Dynamo, so if being able to save your music as a PDF is important to you, MuseScore is one that you should consider. And unlike the Muse sequencer, which is just available for Linux, the MuseScore has been made for Linux, Mac, or Windows. And this is the same piece that I showed you in Dynamo just a few minutes ago in Muse. The visual interface in MuseScore is, I think, it is a little prettier, a little slicker. You can click here, choose the length of the note, choose, flats and sharps and double flats, and that's just what the user interface looks like on MuseScore. Now I'm going to talk a little bit about algorithmic composition. If you like math, algorithmic composition is a lot of fun. It doesn't derive music from a traditionally written out score or a set of looped tracks like the score frameworks or the sequencers I'm talking about. Instead, it uses mathematical methods and functions to define patterns. You can map list elements to musical events. If you want things to be kind of random, you can use different order Markov chains to either make things completely random or make them depend on the last event or last two events or something. You can go crazy just writing out these complicated patterns of what maps to what. I'll start trying to write out some code for algorithmic composition, and I feel like I've been writing code all day, and yet I still haven't fleshed out all the functions or all the sequences of events. It's a lot of fun, and it gets really addictive. The main open source algorithmic music platform, it's Common Music and Grace. Common Music is kind of the back end, the composition framework, and then Grace is the graphical IDE, integrated development environment for Common Music. And what's really cool about Common Music is you have several choices for your composition environment, depending on how deep you want to get into the coding, or really if you want to code at all. There's a programming language called SAL, which is suitable for beginners, and it's specific to Common Music. It's really easy to get the hang of if you've done any kind of programming whatsoever, and it's extremely full-featured. My dirty little secret is, that's the language that I use when I'm doing algorithmic composition. If you want something more complex, more full-featured, or if you're really into functional programming, you can also program Common Music in Scheme, and very well documented. There are a set of Scheme functions that are specific to Common Music. SAL, by the way, is very well documented as well on the Common Music website. Then there's also a graph interface, which I will have a screenshot of later, but if you kind of want to draw a picture or draw out a graph or plot out points, you can use the graph interface to draw pretty pictures, or not so pretty as the case may be, map that stuff out to musical events to your liking, and come out with this really chaotic sounding stuff. That's a lot of fun too. Again, it offers a variety of ways to save music files. MIDI files, which are nice if you plan on screwing around with it in some other program. SAL code or Scheme code, so you can just go back and edit the source code and see how your new source code sounds. So you can save your graphs in XML. You can save them in numeric spreadsheet format. That's just it's an open source spreadsheet program. You can save one composition in any or all of these formats. There are official releases for Linux, Mac OS X, and Windows, and the website is commonmusic.sourceforge.net. Like I said, there's a lot of documentation on there. There are a couple of books that have been published, but it changes and develops faster than the book, so I suggest going on there and reading through the documentation on the SourceForge website. This is a screenshot. This is just kind of the main Grace window that pops up, and if there are any kind of errors or changes to it, it'll pop up here. Sort of like your terminal, if you will. This is a code window for the integrated development environment, and then a bit of just kind of the beginning of a SAL program that I was writing at the time. This is a picture of the graph interface, and you can set the different values here on the axes and make your graph. Obviously, I just made this really chaotic, and when I played it out, it was like kind of like a kid just banging on a piano for a second or two, who has no idea what they're doing. They just want to bang on it and make it as loud as possible. Graph music doesn't necessarily have to be like that, but that entertains me, not gonna lie. Now, I've talked about all these things that you can use to make noises. I've talked about all these things that you can use to define pitches, but how do you connect them together? I was talking about just now the Common Music. You can use that to define, the note lengths and the note patterns and the note shapes, but, if you just open up Common Music, write some code, and click play, you're not going to hear a thing. Common Music doesn't have a synthesizer in it, which means there's going to be nothing to actually make the notes. So basically the question is, do you know Jack? Jack is the Jack Audio Connection Kit, because open source software loves recursive acronyms. It sees your synthesizers, it sees your controllers. You can even have it configured to see other computers on a network. You can work it over the network. And it gets them talking to each other. Technically, Jack is the name of the API. QJack Control is a pretty easy to manage graphical front end to Jack. These programs can run on Linux, Mac OS X, or Windows. This is, I've got here, this is just the information, the Jack messages. This is kind of the control panel to start and stop. This is a QSynth window. It's the same thing that I showed before, but I kind of, where the real action is here, and I'll have another screenshot of working here. You got here your your output ports and your input ports, I don't have anything connected. There aren't any lines there. And this is kind of like your patch bay. If you don't have anything plugged into anything else, nothing's going to happen. So you can see I've got my keyboard plugged into my computer. I've got FluidSynth running. But if I press a key on the keyboard and my jack window looks like this, I'm not going to hear anything. However, if I click on this, click on that, and then use the connect button, it's going to look like this. It's going to connect, and now if I hit any of my keys, my MIDI keyboard is plugged into FluidSynth, and whatever note, whatever tone that I have set up to use on FluidSynth, whatever instrument I have, it's going to sound like that, and I can play my keyboard, and I can listen to my music, and things are set up. And that's pretty much scratching the surface on what to do with a jack, but it's the one major functionality for jack that I go to again and again and again. That's one thing with these music softwares that I honestly find really maddening, is a lot of them seem to try to do way too much at once. Like, I was talking about the sequencers that also are these full-featured digital audio workstations. They're not my favorite because I think they try to do too much. Maybe I'm kind of a Luddite, but I like one program that's really good at doing like one or two things. And, Jack can do a whole bunch of things, and any specific program can do a whole bunch of things. I like having the building blocks, and I like Jack being my glue that holds together these different building blocks that I have running on my system. Now, we've talked about how, what kinds of things will make the noises. We've talked about how to build and shape the noises, and we've talked about how to connect the synthesizers to the controllers. Now, what do you want to do if you have audio files to mess around with? Or if you want to share your music with your friend, Jack Random Non-Composer, you need something to process it. Like I said, MIDI's great if you're composing, if you're making the music, but you're not gonna, your friend across the hallway at work or whatever, if you want to share some of your music with them, you're not gonna say, oh, here's a MIDI file. You're gonna, you got to open this program and connect this with Jack and blah blah blah. You're gonna end up rehashing everything that I'm talking about today, and they're probably gonna be like, I'm not going to go through this much trouble to play this. You're going to want to give it something they can play on their iPod. These Timidity and Lame are some useful frameworks that are open source software. They're also, themselves are command line tools, so I don't have any pretty screenshots. Timidity can also function as a MIDI synthesizer, but what I find it most useful for is if I have a MIDI program and I want to save it as a WAV file, I can use Timidity, and one command, boom, it's changed. And it officially runs on Linux and Windows. You can also port it to it's also been ported to Mac OS X. And then there's Lame. Lame is, well, another recursive acronym that open source people love so much. Lame ain't an MP3 encoder, except for the fact that it is an MP3 encoder. It's distributed as source due to file format restrictions. So even though the software for Lame is open source, MP3 as a format is not, which sucks. Problem is, it's the format that everybody uses, so it's kind of good to know how to convert stuff. You can also interface with other applications as a plugin, which I'll get to in a moment. It compiles on Linux, Mac OS X, and Windows. And if you have a WAV file and you have Lame, you can just type into a terminal lame blah, where blah is your WAV file, and congratulations, you now have an MP3 file of that WAV file. And people won't look at you funny if you send them the file in that format. Audio processing software. A lot of the stuff that I was talking about allows you to configure specific notes, but also what's kind of fun and what a lot of computer musicians also like to do is mess around with stuff that's already in an audio track, like turn that into loops or make it sound different, put it through filters. A lot of the full sequencers, you can do a lot of that. Ardour, Muse, and Rose Garden all have audio processing in addition to MIDI. Another one that I just want to bring up as well is Audacity. That's my favorite dedicated audio processing software, I think, because it, it specifically focuses on that. It does support MP3. There is a lame plugin for Audacity. You don't even have to compile it. And there are official releases for Linux, Mac OS X, and Windows. This is just a pretty basic Audacity. You've got your track here, 1, 2. If you had more than 2 tracks or more than just a left and a right, they'd be down here. You can select different portions of it, put effects on it, make it quieter, make it louder, zoom in, change the waveforms. It's pretty cool. And finally, I'm going to talk a little bit about Ubuntu Studio. After I've gone through all of these programs, rapid fire, one after one after one, it's like, oh, hold it, catch my breath. How am I going to remember all of this stuff? Well, first, like I said, I'm putting my slides online, but if you just want to have all of it at your fingertips without having to go to every website and download every single program that I'm talking about, just look for Ubuntu Studio. It's an official derivative of Ubuntu Linux, and it contains multimedia packages. It's actually got stuff for audio work, video work, and graphics work, although obviously the video and the graphics are a little beyond the scope of this particular presentation. But if you want to play around with open source video or graphics software, Ubuntu Studio can be a good place to start. It contains every program that I've talked about here except for Rose Garden. But if you want to play around with Rose Garden, that's really easy to get. There is an official Ubuntu package for that. It just, for some reason, which I've never quite understood, doesn't come with Ubuntu Studio. And it's a good platform to be in experimenting for several reasons. If you've never used Linux before in your life, Ubuntu is still pretty easy to get the hang of. The graphical environment is pretty easy to figure out. If you're used to running Windows or Mac, you've still got like a button that drops down the menu, gives you the applications, and it's a pretty low learning curve even if you're new to Linux. It can be run as a live CD, which means you put the CD in, you boot, you tell your computer to boot from the CD, and that's running as your operating system. And you can run that without touching, modifying any of the files or the operating system that you already have running on your computer. So you can just have it as a dedicated music environment without eating up any of your precious hard drive space or trying to figure out, oh God, I'm scared to partition my hard drive, I can't dual boot, which was me until about 2008. I was so scared to do anything that involved messing around with my hard drive because I was afraid I was going to fry it. And also, it's pre-configured for multimedia work. Sometimes getting Jack up and running to start with, or getting any of these programs up and running to start with, it can be a pain in the butt because you have to make sure that your user is configured in the audio group, and not that hard if you've been using Linux for a while, but if you haven't, it can be a little daunting, a little scary if your focus is on, okay, I just want this to make loud, obnoxious noises. So it's pre-configured. You don't have to mess around with any of that junk if you're just booting from Ubuntu Studio, and you can focus on the making music as opposed to the how in the world do I configure Linux. That's it. I've kind of gone through the basic building blocks of computer music, programs that you can use that are open source. Have a question? Yeah. Mm-hmm. I've never actually heard of, well, since he didn't have the microphone, I'm going to kind of digest his question. His question is basically, it's hard to find the right sound. Do I know of any kinds of programs that will randomly spin the dials and then you can stop, go back and find what it is that made that really cool sound that you want to keep using? I don't know of any programs that do that. As far as trying to find out sounds, I mean, I do trial and error. I'll start with sounds that I already have in banks and then start twisting the dials myself, and sometimes that sounds cool and sometimes it doesn't. I'd have to look around for that and get back to you because I don't actually know of a synthesizer randomization program. It should. If it doesn't, it should.
It
Yes?
So, you're sitting down to your computer in a creative mood to have them return the CD. What's the workflow?
It depends on my mood, really. I mean, most of the composition stuff that I like to do, my favorite things to do. A lot of my workflow involves, okay, I've got this melody in my head, and since my personal workflow definitely focuses on more traditional musical notation, I'll plug my keyboard in, hook it into usually QSynth Fluid Synth nowadays. Used to be Xenad SubFX, but nowadays it's QSynth Fluid Synth. I'll start playing around, make sure that I've got the notes for the line that's ringing in my head, sketch that out, and then I will write it out in a score framework editor. For me, usually Dynamo, but I'll write it out in a score editor, and then try to write harmonies for it. It's very my workflow, at least at that stage, is very similar to sitting down at the computer equivalent of sitting down at the piano with a piece of staff paper and kind of writing out, playing through it. Sometime, and then once I've done that, once I've written it out and I've fleshed out the idea, fleshed out how I want it harmonized, then if it's something that is intended for live performance or for singing, then I don't really do a whole lot with messing around with the synthesizer sound. I'll probably save at least like an MP3 of it. Save it as a MIDI file, put it through Timidity, and then put it through Lame as an MP3. Maybe print out an image file of the score if I want to share it with my friends, and maybe try and have them sing it. If it's my other kind of favorite thing to do is algorithmic composition. That's the workflow for that is very much like sitting down trying to write a piece of code. It's there, I'm defining these functions. Oh, that doesn't really loop around or sound the way I quite want it to. Oh, these notes aren't quite what I want them to be. And then that's really not intended to be performed by anything other than a computer. So then there's a little bit of what I was mentioning with his question, kind of, okay, what kind of notes do I want this to sound? Trial error, what sorts of ranges of instruments or wave shapes do I want this code to even generate? So it really depends on the type of music that I'm trying to write, my workflow. It's scatterbrained and all over the place, just like me. Any other questions? Yes? I know that there was a day when I didn't know what to measure a quarter note or whatever it was. My parents had like the Methodist hymnal sitting on the bookshelf, and I'd flip through. It's like, what are these funny looking things that I can't read?
Because it's a Methodist hymnal. That's why.
Well, no, and then, once I was like 7 or 8 and taught myself how to read music, it's like, oh, that's what it is. But before that, I'm like, what? So yeah, music notation, just like any other particular jargon, can be a little weird. Yes? I've really, when I try to record my voice into a computer, that's generally what I use Audacity. That's one of the things I like to use Audacity for, because not only is it, is it really good at, processing and messing around with sound that already exists. I mean, if I'm singing or if I want even just, talking, speech recorded, when I want to record something, I usually use Audacity. Thank you all very much for coming.